Direct and inverse proportions. Consider an example. Cost of 5 pencils is rupees 10. What will be the cost of 10 pencils? The cost of 10 pencils will be rupees 20. Here we see that the number of pencils increases. The cost will also increase. Hence, they vary directly with each other. Now look at this table. It is clear that more the pencils, more the cost. Less pencils, less cost. So we conclude that if one quantity increases, the other also increases, or when one quantity decreases, the other also decreases. This is known as direct proportion. Mathematically, we can write it as xy is equal to k or x is equal to ky. Now comes the inverse proportion. Consider another example. A person can go to his destinations in 4 different ways. He can walk, he can run, he can go by a bicycle, or he can go by the car. We have noted the observations in a table. We see that as the speed increases, the time decreases. In other words, we can say that the ratio by which time decreases is the inverse of the ratio by which the corresponding speed increases. This is inverse proportion. If two quantities x and y are related in such a way that the product xy is equal to k, where k is the constant term, then x and y are said to be in inverse proportion. Now let's solve an example. 3 workers built a wall in 12 hours. How long would it have taken for 6 equally productive workers? In this example, the number of workers and the time are inversely proportional, because when the quantity of people decreases, the total time increases, and when the quantity of people increases, the total time decreases. To solve the sum, make 2 columns, one of workers and the other of time. Invert one of the ratios, flip it upside down. Cross multiply, divide and solve. Therefore, 6 workers will take 6 hours to build the wall.